Okay, so this past class we talked about percent composition, and we could maybe define this a few different ways, but for this class we said it's the percentage by mass in the compound. So really it's this grams of the part divided by the grams of the whole. And remember, when we want to turn these fractions into percentages, we're just going to go ahead and multiply that by 100% to give us a percentage. So the example I liked in class was, what percentage of each of these elements, copper, sulfur, and oxygen, are in the compound copper 1 sulfate, CuSO4. So in this compound, the copper occupies 63.55 grams of the total 159.62. The sulfur occupies 32.07 grams of the total 159.62. And the oxygen occupies 64 grams of the total 159.62. So to find out the percent composition in this compound, we could just divide each of these by the whole, these parts by the whole, and then multiply by 100%. So then we can find out that copper occupies 39.8% of the compound, sulfur occupies 20.1% of the compound, and then oxygen occupies 40.1% of the compound. And remember, this is talking about the percentage by mass. So let's look at some of these sample problems here. So I'm really trying to work our way up to understanding what this all means. So what is the molar mass of just H? Let's look at our periodic table here. Let's get rid of this. And the molar mass of hydrogen is 1.01 grams per mole. What's the molar mass of H2 then? Well, I would just double that value, 2.02 grams per mole. What's the molar mass of one oxygen? Oxygen is 16.00 grams per mole. What's the molar mass of H2O then? We would just add these values. What's the mass of two hydrogens? 2.02. What's the mass of one oxygen? 16.00. Together they make up water, so the molar mass of water is 18.02 grams per mole. Now, what percentage of H2O is hydrogen? All we gotta do here is look at the part and then divide it by the whole. So the hydrogen was 2.02 grams. Now we need to take into account that there were two of them there. The total was 18.02 grams per mole. And then if we want to find a percentage, we would have to multiply this by 100%. So on the calculator, we take 2.02, we divide it by 18.02, and we get 11.2%. Now, what percentage of H2O is oxygen? The oxygen was 16 grams per mole, the part. There's only one of them there. And then the total was 18.02 grams per mole. We multiply this by 100%. We divide 16 by 18.02. We multiply it by 100, and we get 88.8%. So water is about 88.8% oxygen by mass and 11.2% hydrogen by mass. So that's what this really means. Now here's some extension problems. Let's say we had 100 grams of water. What mass of hydrogen is in this sample? Now I think you could just look up at these percentages and just say like, oh, 100 grams of water, hydrogen's 11.2%. That would be 11.2 grams. But let me show you the way that's going to work every time. I would set up ratios. So 2.02 grams per mole is hydrogen. The sample is 18.02 grams per mole. So it wants to know how many grams of hydrogen would be in a 100 gram sample. So I like to set up a little ratio here and say 2.02 grams per 18.02 grams equals X grams over 100. And what you find out when you cross multiply here is you do end up with 11.2 grams of hydrogen in the sample. But this method is going to work when this value is no longer 100. So here's a good example of that. If we had 165.3 grams of water, what mass of oxygen is in the sample? So oxygen was 16.00. The whole was 18.02. Now we want to find out X grams per 165.3. So you would divide 16 by 18.02. And then you multiply that by 165.3. So we're kind of just cross multiplying to solve for the X. We find out that there are 146 0.8 grams of oxygen in 165.3 grams of water. So this is where this method will really benefit you. Let's keep practicing. What mass of carbon is in 100 grams of CO2? So carbon is 12.01. We look at 1 carbon plus 2 oxygens, and that total is 44.01. So let's do 12.01 for carbon divided by 44.01 for the CO2 equals X grams over 100. We divide 12 by 44, we multiply it by 100, and we get 27.29 grams of carbon. Notice I'm going to try and have 4 sig figs here if that was the information provided to me. So 27.29 grams of carbon would be found in 100 grams of CO2. What about if we had 100 grams of carbon monoxide, CO? What mass of carbon is in that? So now I need to write down that the molar mass of CO is just 28.01 grams per mole. Let's keep with the ratio method. We have 12.01 grams of carbon in there. There's only 1. Divided by the whole, 28.01, equals X grams over 100. 12.01 divided by 28.01 times 100, and we end up with 42.88 grams of carbon in that 100 gram sample. I'm going to skip down here to 4 just so we can get another one so we're not dealing with 100. So what mass of carbon is in 12.5 grams of CO2? 12.01 grams for our carbon. That's our part. The entire thing is 44.01 grams. That's going to equal X grams over 12.5 grams, what we were given. So we're going to divide 12.01 by 44.01 and then multiply that by 12.5, and we find that there are 3.41 grams of carbon found in 12.5 grams of CO2. Okay, what about this last question? Which element occupies the most mass in a 100 gram sample of copper 1 nitrate, CuNO3? So for this problem, since we're dealing with the same amount here, I think we can just look at the masses of these 3 elements and just choose the one that has the greatest mass. And that'll be the greatest part in the whole. So if we look at the periodic table, copper is 63.55 grams per mole. Nitrogen is 14.01 grams per mole. And 3 oxygens, so 3 times 16, so we get 48 grams per mole. So for copper nitrate, we can see that copper is the element that occupies the most mass in the compound, or in that formula unit. Okay, I hope this helped. Keep watching.